Hi guys, and welcome to another video. In today's video lesson, we're going to be looking at grade 12 maths algebra, challenging questions from past year exam papers from 2010 to 2019 part 3. The question that we're going to be looking at today is from the May-June 2018 examination paper, and it reads as follows. Question 1.4 says prove that x squared plus 2xy plus 2y squared cannot be negative for x and y element of real. So for all real values of x and y, we must prove that this particular expression x squared plus 2xy plus 2y squared cannot be negative. Now, what cannot be negative? Well, squares cannot be negative. Anything squared is a positive value. So let's think about that when we're answering this particular question. So if you look here, you've got x squared and you've got y squared there. So that reminds us of a quadratic. So if you look very carefully, you can now say that this particular expression will equals to x squared plus 2xy plus y squared plus y squared. And if you look at that, you can now factorize that to x plus y all squared plus y squared. So if you have to test this expression out, x all squared is x squared, double the product, x times plus y times 2 is plus 2xy, plus y all squared is plus y squared. And here you got, remember, y squared plus y squared is 2y squared. So therefore, if x plus y is squared, therefore we can now conclude that x plus y all squared will be positive for all x and y element of real, and also y squared will also be positive for all y values, so for y element of real. Okay, so once again, it's important for us to recognize the following binomial squared. So if you have x plus y all squared, I think the important thing for us to remember in this question that x squared plus 2xy plus y squared. And remember that you got 2y squared, so all you needed to do was add another y squared like so, and therefore now it becomes x plus y all squared plus y squared. Well, easier said than done. So in future we must look out for things like that to recognize x plus y all squared and so on. But the important thing to remember in this question is that squares or perfect squares cannot be negative. So anything squared cannot be negative. Let's look at the next question. The next question that I want to look at is from the May-June 2016 examination paper, and it reads as follows. We need to solve for x here. X minus 3x to the half equals to 4. Now, so if we look at this particular question, we can have the following. So it will be x minus 3x to the half minus 4 equals to 0. Let's factorize this. Now this can be factorized as follows. X to the half times x to the half will give me x. X to the half times x to the half is x. Because remember, when you multiply common bases, you add half plus half is equal to 1, right? Now, factors of minus 4 when multiplied together to give me minus 4 and added together to give me minus 3. So that will be 1 and 4. Let's get the signs right. It will be positive 1 and negative 4. Let's test it out. Plus 1 times minus 4 is minus 4. And if I add plus 1 to minus 4, I'll get minus 3. So let's now go and solve x. So we're going to get x to the half, which will equals to minus 1, or x to the half, which is equal to 4. Now x to the half cannot equals to minus 1. So we're going to write not applicable. Now I'll explain that just now. But here x to the half, if we square both sides, we'll get x equals to 4 squared is equal to 16, and that would be my answer. Now there's another way that we could have done this particular problem. If we treated it as an equation with surds, for example, it will look as follows. It will be x. So if you have to look at that, it will be x. If I bring this 4 to the left hand side, it will be minus 4 equals to minus 3x to the half become positive 3x to the half. Now we know that 3x to the half, remember x to the half is equal to the square root of x, like so. Okay, remember the rule, that's a 2 there, that's a 1, so it will be x to the 1 divided by 2, according to this rule here, which is the nth root of x to the m is x to the m divided by n. Okay, now that we know that x minus 4 is equal to 3 root x, so we can square both sides now because it becomes equation with surds. So you'll get x squared, double the product there, so that will be x times minus 4. I'm squaring both sides here. Okay, so that will be minus 4x times 2 is minus 8x and plus 16 equals to, so if I square that now, it will be 9x. So then I'll have x squared minus 17x plus 16 equals to 0. So let's factorize this now. So if you factorize it, it will be x times x. Factors of 16 will multiply together to give me positive 16, and when added together to give me minus 17. It will be 1 and 16 minus and minus. So here I got x equals to 1 or x equals to 16. So now if I do my test, as you can see, if I put 1 minus 4, that's minus 3. So I can't have negative on one side and positive on the other side. And if I substitute 1 here, 3 times the square root of 1 equals to 3. So you can see one side I'm getting minus 3, the other side I'm getting plus 3. So therefore that is not applicable. And here x equals to 16. 16 minus 4, do your test. 16 minus 4 is 12. And if I substitute the side, 3 times the square root of 16. Square root of 16 is 4. 4 times 3 is 12. See, positive 12, positive 12 on both sides. So therefore this is my answer. So then we will now write x equals to 16 is our solution. So you can see one of two ways you could have solved this particular question. It's important to reject the answer here that is not applicable. Okay, let's look at one more question. Now in this particular question here, as you can see, we got the November 2010 paper. Calculate the integer that is the closest approximation to this particular expression here, which is 5 to the 2007 plus 5 to the 2010 all over 5 to the 2008 plus 5 to the 2009. Show all working. Okay, so let's look at that very carefully. So here you got now 5 to 2007. So your smallest power is 2007. 2010, 2008, 2009. In a previous video, I told you that you need to bring all these to the smallest power that you have here. So you're going to say 5 to the 2007 plus. Now 5 to the 2010 can be expressed as 5 to the 2007 times 5. Remember 2007 plus 3 is going to give you 2010. Right? And that's going to be all over 5 to 2008 is going to be 5 to the 2007 times 5 to the 1. 2007 plus 1 is 2008. Remember 2007 plus 3 is equal to 2010. Which rule are we using here? Remember x to the m times x to the n is equal to x to the m plus. Okay, so we're just breaking it up using the law of exponents. 5 to 2009, so that will be plus 5 to the 2007 times 5 squared. 2007 plus 2 is 2009. Now the reason that we break it up is because you can now remove a common factor here. So you've got 5 to the 2007, 5 to the 2007, 5 to the 2007, and also 5 to the 2007 there. So you can remove that now as a HCF. So let's do that. 5 to the 2007 into 1 plus 5 cubed all over 5 to the 2007 into, what am I left with here? 5 to the 1 plus 5 squared. So 5 to 2007 cancels with 5 to the 2007. So I'm left with the following. So let's put that in our calculator and see what we get. So it'll be 1 plus 5 cubed all over 5 plus 5 squared. 5 to the 1 is 5, right? So it'll be 5 plus 5 squared equals to 21 over 5. So that'll be 21 over 5. Now the question says that they want calculate the integer that is the closest approximation to that. Right? Remember, an integer is a positive or negative whole number, including 0. So let's get that. Decimal 4.2. So therefore the closest integer will be 4. Learners, that is our solution. If you haven't subscribed already to my YouTube channel, Justin Lazarus or JR Maths, my Facebook page is Justin Lazarus Mathematics. You can also catch all videos on jrmaths.com in order of the work schedule, and I'll catch you in the next video.